Hey everyone, in this video I'll be going over how to find the amplitude, period, midline, domain, and range from a sine or cosine equation. I was just going to check out my previous video where I went in detail on how to find the amplitude and period from a sine or cosine equation, but if not, that's okay. I'll go over a quick refresher on what you need to know. So the first thing you want to know is the formula that is used to create an equation like the examples over here on the left. So we have the equation goes like this, the formula. Y is equal to A cos or sine B times X plus C plus D. So that's a formula you're going to see. Now, each variable here, so A, B, C, or D, each impact the graph in their own different way. And each of these A, B, and C, and D, they all determine a separate transformation. But I'll go quickly in detail of what each of these variables mean. So the A variable determines the number 1, the amplitude. So the amplitude is just the height that the graph goes past the midline. So if I were to draw a quick graph here, let's draw a quick graph here. And it looks like, let's just say, a sine graph. Let's just take the amplitude. To find the amplitude, it would just be from this x-axis, or not always the x-axis, but just from the midline. In this case, the midline is 0. So from where y is equal to 0, all the way to the top of the graph. So that distance between that top to the midline of 0 here is the amplitude, so that distance. So same thing from here all the way down. So those are supposed to be equal, but on an actual graph they will be equal. So the second thing that the A value determines is the vertical stretch / compression. So you might have seen this before in Algebra 1 and Algebra 2 and possibly previous units in pre-calc. This is just a transformation. So in these sine and cosine graphs, each variable determines a different transformation. And in this case, the A value determines the vertical stretch / compression. Now, let's take the B value. So the B value, this number 1 helps find the period. So the B value helps find the period. Now the key word here being helps. Helps. So let me make a side note. The B value is not the period. So the B value is not the period. It helps find the period using the equation for sine, cosine, secant, and cosecant graphs, using the equation 2 pi over b. So that 2 pi over b, when you plug in your b value, it becomes the period. But that b value directly is not the period. And that same rule applies to converting a graph into an equation. You can't directly take that graph period and put it into the equation. You have to use this 2 pi over b formula. Now, the second thing that the b value determines is horizontal stretch / compression. So horizontal stretch / compression. So just like the A value determines a stretch or compression, but in this case it is horizontal and the A value is vertical. So look at C. So C is even easier. It is just vertical. C value is just horizontal phase shifts. And that just means right and left movement. So when you see a C value in an equation, you know that the graph is shifted either right or left from the parent function. And then we have our final one, which is d value. So just as easy as the c value, it determines vertical phase shifts. So that would be up and down movement. So this d value, if you see a d value in the equation, you know that the graph has shifted either up or down from the parent function. And now one tricky thing you might want to note about the c value is that it's in those parentheses. So the c value is in those parentheses, so you have to set that x plus c value is equal to 0. So that's tricky. So that means you would get x is equal to negative c. So whatever your c value is in that parentheses in the equation, you would take the opposite of that, and that's your actual c value. And the d value is just straight. There's no tricky stuff there. It's just if it's positive d value, it's up. If it's negative d value, it's down. So that's just a quick refresher that we just went over. So let's look at some of these practice problems. So let's look at number 5. We have y is equal to 1 over 3 sine 2x. So let's go ahead and break down this equation into our formula. So by labeling each part of this equation as either B, C, D, or A, we can easily plug in those values into certain equations and then solve all of these questions that we have below. So let's first find what our A value is, since it's at the start of the equation. And in this case, the 1 over 3 is our A value because it is right in front of that indicator, that sign. It's right in front of that sign. It could be cos, so whatever is right in front of that sign or cos is your A value. So here we can just label this as A. Then we have our indicator, so that's sine, so we know what the graph will kind of look like. We've got a general idea of what it will look like. And then we have, right after that sine, we have a 2, so now we know that 2 is our C value, our B value, our B value. Whatever comes right after that indicator is our B value. Now, after that B value, we see an X, but there's no attached C value. There's not another value in a parentheses after that X, and there's no D value here either. So we can assume that both the C and D value are 0. Now, the amplitude, as covered in the last video, is just the A value. The amplitude is just the A value. No tricky stuff there. So when you figure out your A value, you just plug that in to our amplitude. And you might want to note that the amplitude can never be negative. So even if you have a negative sign right in front of that whole equation, the amplitude is still a positive value. So in this case, if this were to be, hypothetically, if this were to be a negative 1 over 3, your amplitude is still a 1 over 3. So let's look at period. Now remember, to find the period, we have 2 pi over b. So let's go ahead and just plug that into our equation. We have 2 pi over b is equal to 2 pi over, and our b value is 2, is equal to, the 2's cancel, becomes pi. So our period is equal to pi. Now the midline, it might be new information. So the midline is very easy. So this just comes directly, the midline comes directly from the D value. So whatever your D value is, that's going to be your midline. But the tricky thing about midline is that it is an equation. So the midline is y is equal to 0. So it's not just 0, it's y is equal to 0. So now we have domain. Now for sine graphs and cos graphs, the domain is always just all real numbers. When you get to later equations, like using like secant, cosecant, tangent, and cotangent, the domain might not always be all real numbers. But in the case of sine and cosine graphs, it is always all real numbers. So no tricky stuff there. So it's just all real numbers. Now let's look at range. So the range is a little tricky, but it is essentially just to find the range, you have to look at amplitude. So you have to look at the amplitude of the equation, and then you have to look at the midline. So that's why the midline is important, because it gives you the middle of the graph and it helps you find the range. So the range is essentially just the midline. So it's essentially just the midline plus or minus amplitude. So this is just for sine and cosine graphs only. The other stuff, so the secant, cosecant, cotangent, tangent, that has different way of finding the range. But for sine and cosine graphs, the midline plus or minus the amplitude is your range. So let's just take a look at this one. So we have midline as 0. Let's just plug into this formula that I gave. So we have a midline of 0 plus or minus 1 over 3. So that means, first we have 0 minus 1 over 3, because you have to list your lowest value first when putting down the range. So we have minus 1 over 3, comma 1 over 3, because 0 plus 1 over 3 is just 1 over 3. And remember, you want to put the brackets instead of the parentheses, because when you're putting brackets, it means that the graph is touching this point. And since it's not an asymptote, the graph will touch negative 1 by 3, and 1 by 3, so it should be brackets and not parentheses. Let's look at number 6. So now that you've got the general idea, I'll go a little faster here. So we have y is equal to cos x over 2 plus 1, and there's no value in front of that cos, so that means, instead of like the previous problem where there's a 1 over 3, there's actually nothing here, so we can assume that the a value is equal to 1. If there's nothing there, we assume the a value is equal to 1. It's not 0, it's 1, so that might be a little tricky. Then we have our indicator, so we have that cos that tells us what the graph might look like, a general idea, before all this transformation stuff. And then we have x over 2. Now the x over 2, that might be new, where you haven't seen that x on top of that 2 instead of on the side. But all that is x over 2 is equal to 1/2 x. So in the problem, they're just bringing the x to the top, because if you were to expand that 1 over 2x, you would multiply the x by the numerator and then keep that denominator. So it just becomes x over 2. But for the purpose of breaking down this equation, you can write it as 1/2 x. And since it becomes 1/2 x, we can assume that 1/2 is our b value. Because remember that x is not included in that b value. It's just the number in front. So that's our b value. And then we have no c value because there's no parentheses here, so we can assume the c value is 0. So c is equal to 0, and then this guy right here on the end is our d value, that 1. Since it's not in parentheses, we can assume that's the d value. So the amplitude is directly our a value, so we know that our answer for amplitude is 1. Then our period, let's plug it into this equation, 2 pi over b. So 2 pi over 1/2, and then you bring that 2 to the top, just simple division is equal to 4 pi. So once you get 4 pi as your period, you can move on to midline. And then remember the midline is our d value. So our d value is the midline. So it is y is equal to 1, because our d value was 1. And remember, the midline can be negative, so there's no restrictions on negative. Only the amplitude can't be negative. So the midline in this case is 1. Then remember, domain for sine and cosine graphs is all real numbers. So be sure when you're starting this problem, if you're asked for domain and range, you see what function it is. So if it's a cos function or a sine function, you know that the domain is all real numbers. So now let's look at range. Now let's plug in to our value again. Remember midline plus or minus amplitude. So we have our midline at 1. So midline is 1 plus or minus, and then our amplitude is also 1. So you want to start with the negative. So 1 minus 1 is equal to 0, and then 1 plus 1 is equal to 2. And that's our final